So guided practice, graphing polynomial functions. So 6a, we're given a function and it's in factored form. So we need to apply the leading term test, determine the zeros and state the multiplicity of any repeated roots, find a few additional points and then graph the function. So we'll start with applying the lead term test. So let's just do that. So if I was to rewrite, so I'm going to just rewrite my function. So with the term, so I've got minus 2x squared and then 3 cubed. So that is going to be 27x cubed. So this would be minus 54x to the 5. So my leading coefficient is minus 54, which is negative. The degree is 5, which is odd. So my graph, I know, is going to start up here and it's going to do something like this. So we know also that the turning points will be 5 minus 1. So we will have also a maximum of 4 turning points. So now we need to write the limits. So the limit as x approaches infinity, so let's do it this way, as x approaches infinity, f of x is going to be approaching negative infinity. And as x approaches negative infinity, f of x is going to approach positive infinity. Okay then, and part B, determine the zeros and state the multiplicity of any repeated zeros. So I'm just going to rewrite the function. So f of x is minus 2x, x minus 4, and 3x minus 1 cubed. We're going to make this equal to 0. So we have minus 2x is 0, x minus 4 is 0, and 3x minus 1 is equal to 0. Now this is going to be, it's cubed, so there's going to be 3 repeated roots. So we have x is equal to 0, x is equal to 4, and x is equal to a third. And it's going to be a multiplicity of 3. So the roots, so the 0 roots are at x is 0, x is 4, and x is a third, but they're repeated. So this is repeated, a repeated roots. Okay, so C, find some additional points. So we have our intervals, so between the roots that we've actually found, so we found the roots at 0, a third, and 4, we need to choose some points. So I've chosen minus 1, a quarter, 1, and 5. And then substituting the values into f of x, we can actually find our coordinates to plot. So part D, we now need to graph our function. Okay, so if we graph our function, we will see that we have our roots. So we have a root at 0, and then we have repeated roots. So we have a root at 4, but we have our repeated roots here, which is at a third. And when we have our repeated roots, it's going to increase. And because there are an odd number of roots, it will then decrease. Okay, so the first thing we need to do, we got a function 6b. This time it is not in factored form. So we're looking at the leading coefficient. We're going to apply the lead term test. So you can see that the coefficient, so the leading coefficient, is -1. And the degree is 3, which is odd. Now the turning points will be 3 minus 1, which is 2. So it's going to be a maximum of 2 turning points. And we're going to have 3 roots. So the limits, or if we were to draw our graph, so this is a negative graph, and it's going to do something like this. So we know that we can see the limit as x approaches negative infinity, f of x will approach infinity, and then as x approaches, so that should be an arrow, let's change that. So as it approaches infinity, f of x is going to be approaching negative infinity. So part C. Oops, so that was A, sorry. Part B. So distinct roots. We need to find any roots. We need to say if they are repeating. So we need to factor. So we've got minus, just writing our function again. And we're going to factor by minus x. So this will give us x squared. And this will be minus 2, 2x, and minus 8. So looking for factors of minus 8, that will give us a difference of 2. So this is going to be x. So we've got 4 and 2, and we want it to be minus. It's going to be minus and plus. So making this equal to 0, so minus x is equal to 0, x minus 4 is equal to 0, and x plus 2 is equal to 0. So x is 0, x is 4, and x is minus 2. So we have 3 roots and no repeated roots. So we say no repeated roots. So no multiplicity. Okay, so part C, we need to find additional points. So we're looking between our roots that we found. So we're going to use, I'm using -4, -1, 2 and 10. And just substitute them in to get our additional points. And then we can look at graphing the function. Okay, so this is our function, and we have, you can see we have roots. So roots at -2, at 0, and at 4, and there's no repeated roots.